If you're looking to expand your population, one way is to go out and colonize alien planets in other solar systems. Another is just to build your own planets. But if you like having a lot of elbow room, nothing quite beats a Ringworld. So today we are going to be looking at a type of megastructure called a Ringworld, a giant ring-shaped structure that goes all the way around a star and contains vastly more living area than Earth. It was popularized in the novel Ringworld by Larry Niven, and unsurprisingly, this is our book of the month, sponsored by Audible. You can grab a copy of Ringworld by using my link audible.com/Isaac, or click on the link in the description below. That gets you a free audiobook and a 30-day free trial of Audible. The novel came out in 1970 in Niven's Known Space series, and while that includes a lot of great short stories and other books, many written before Ringworld, that novel became what the setting is best known for and spawned several sequels itself and a few aborted attempts to bring it to film or television. It's not hard to see why either. There's tons of other fascinating themes, aliens, and technology in that novel, and the series in general. I'd recommend reading it even without the famous megastructure, but the sheer scope of a Ringworld captures the mind. Since I will be discussing that object in detail today, I do want to emphasize that how it functions isn't the important part of that book, and the story has tons of other fun elements I won't be spoiling today. We have discussed Dyson Spheres in the past, and how the rigid kind don't work, but you can do a swarm of objects instead. The big problem with a rigid sphere is that there's no gravity on the inside of it, so everything falls down into the sun. Even if you spun the object to produce centrifugal force acting as gravity, only near the equator would you have full gravity, and at the poles you would have none. Niven suggests just going with that, an equatorial slice of a rigid Dyson sphere. It's smaller than a Dyson, swarm, or sphere, but unlike the swarm, which is physically possible, it has all of its land area connected, and unlike the sphere, which physically is not, this works, more or less. Here is the basic concept, much like any rotating habitat. You take a big ring or cylinder, spin it around quite fast, and those on the inside are shoved against it by centrifugal force, or by their own inertia if you prefer. Since we are going to be spending a little more time than normal on the physics and engineering aspects of things, I might as well go ahead and address that. I reference spin gravity and centrifugal force here a lot, and so a lot of folks assume I bypass calling centrifugal force a pseudo-force or imaginary force to save time, which is partially true but mostly not. Centrifugal force is an inertial force, or a pseudo-force or fictitious force, in the sense that it only appears real when you treat an accelerating object as stationary. Of course, in physics, 99% of the time we are actually doing just that, and every time you think of yourself as standing still, sitting still, or stopping, you are too, because the surface of Earth is a non-inertial reference frame that has inertial forces acting in it. But the bigger issue is that if someone says to a physicist, centrifugal force isn't a real force like gravity, they will not get a nod of agreement, but more that grimace we tend to reserve for when the correct answer is very hard to quickly explain. You see, under Einstein's general relativity, gravity is also an inertial or fictitious force. So saying centrifugal force isn't real, but gravity is like saying that the shadow a man casts is not a real thing, but his reflection in a mirror is. You can make the argument neither is real, or both are real, but for pretty much all practical purposes they are real enough, and the same for gravity or centrifugal force, which can be used to mimic gravity. More importantly, if we do make a big cylinder or ring and spin them around quite quickly, the apparent force holding you there is going to feel quite genuine to you, and if you jump up from it, you will fall right back down too, just like with normal gravity. In a rotating frame of reference, that is because centrifugal force is pulling you back down. To an observer watching from outside, you didn't really jump up, you jumped up a little while flying forward in the same direction as the spinning ring, and ran back into it at about the same place on it you left. This is our only current trick for generating artificial gravity. They have the classic sci-fi kind in the book too, but not so cheap that you can cover planets with it. Now, how much force or acceleration you feel, how much gravity, is entirely dependent on two variables: how fast the thing is spinning, either given in its actual velocity or tangential velocity in meters per second or miles per hour, or its spin rate, rotations per minute, and how wide the thing is, its radius or diameter. The default equation is that acceleration is equal to the square of the velocity over the radius, and you want that acceleration equal to 9.8 meters per second for Earth gravity. This means that a ring that has 224 meters in radius and spins around twice a minute, having a tangential velocity of 47 meters per second or 105 miles per hour, will seem to have normal Earth gravity. Since spinning around more than twice a minute can cause nausea, we usually consider this the safe minimum size for any cylinder or ring meant for comfortable, long-term use by people. But of course you can go bigger. Take that same ring and make it twice as wide, and gravity will drop to half, making it 4 times wider, and the apparent gravity will drop to a quarter of what it was, 10 times wider, 1/10 the gravity, and so on. To keep up the proper gravity, you need to spin it faster. A ring 4 times wider will need the velocity to be twice as high. Again, it is velocity squared over radius. You don't need to worry about nausea though, because even though it's spinning twice as fast tangentially, it now has 4 times the radius and circumference, so it takes twice as long to spin around, 1 rotation per minute, not 2. Now, to make something big enough it would wrap around an entire star at about the distance Earth is from the Sun, 1 AU or astronomical unit, and give it Earth gravity, would require that it spin around not once or twice a minute, but about 40 times per year, every 9 days, and that it have a velocity of about 1200 kilometers per second. That's one of those ridiculously huge numbers. Sounds small compared to the speed of light, 0.4%, but it is also over 100 times the escape velocity of Earth. If you had a ring spinning like this, you could jump off the side and fly off into interstellar space and arrive at Alpha Centauri in about 1,000 years. It also means that anything that smacks into it is going to do a lot of damage, because their relative velocities are a lot higher than a meteor hitting Earth's are. It is a speed at which a person who weighed 86 kilograms or 190 pounds slamming into it would release exactly the same explosive force as the Hiroshima bomb. Needless to say, you want to have some powerful anti-meteor defenses on such a thing, though since you need to clear out just about every bit of rocky matter from your solar system to build one, it maybe isn't such a big issue. Of course, you could also build it out of something very tough too, and you have to anyway, because spinning an object that fast puts enormous strain on it. Whenever building a rotating ring, the force it is under in terms of stress is the same as a suspension bridge with a length equal to the ring's circumference operating in the same apparent gravity. It's fairly difficult with modern materials to build a suspension bridge even a kilometer long, though most of that has to do with other factors like wind that isn't an issue here. And even stuff like carbon nanotubes and graphene maxes out at about 1,000 kilometer radius for a rotating habitat. It's also nice to have some margin for error and damage, so you don't want to go to the maximum. Plus, everything you load inside that habitat, all the dirt and air and water, weigh down on it just like a bunch of vehicles do on a bridge. So unless you want the structural shell to be much more massive than the stuff inside it, you have to make it even smaller than the theoretical limit the material allows, which, incidentally, is the same breaking length we discussed in the Space Elevators episode of the Upward Bound series. We don't have any material that could even vaguely permit a ring a whole astronomical unit in radius, so the Ringworld is usually thought to be confined to fiction. But we will challenge that and discuss some options in a bit. It is worth noting though that this is why so many of us who discuss this topic often prefer a giant swarm of smaller rotating habitats instead. since their main disadvantage compared to a ringworld is you can't walk from any given point on them to any other point in the swarm, which is unfortunate but not really an inconvenience for any civilization capable of building such things anyway. And as we saw in the Dyson Spheres episode, you can create a variant called a rung world that still lets you walk around the whole thing, even if you might have to do occasional brief stretches in low or zero gravity, though these can still have air and even water if you don't mind employing some pumps. The big disadvantage of rotating habitats in general, the normal kind or ringworld, is the daylight. On a normal O'Neill cylinder, you are spinning around every other minute, so you not only need an elaborate system of mirrors to get the light inside the can, but wouldn't want to see the outside anyway. It's probably rather unpleasant to see the sun rise and set every 2 minutes. The O'Neill cylinder's much bigger brother, the McKentry cylinder, which is 100 times wider, takes the square root of 100 or 10 times longer to spin, about every 20 minutes. As I mentioned, the ringworld itself spins around every 9 days, but since its light source is inside it, the sun does not rise or set or even move. It stays in the middle of the sky, all day, every day, all the time. This is an irritating feature, and one that can be addressed, but it is worth noting that for any given simulated gravity strength, there will be exactly one ring radius that fits a specific day length. For Earth gravity and day length, 24 hours, that would be a ring 1,857,000 kilometers in radius, or just over 12 million kilometers in circumference, and it would need to spin at 135 kilometers per second, not the 1200 of the ringworld. To simulate Martian gravity and day length, which is about 40% of Earth's gravity and just a little longer than our day respectively, would require only about 40% of the speed and radius. For any given planet, with a given surface gravity and day length, there will be exactly one radius and spin rate that can mimic it. We call this a Banks orbital, and it is the ringworld's little brother, first popping up in the novel Consider Phlebas by E.N.M. Banks, book 1 of his cultural series, which I'd also recommend. They are hundreds of times bigger than Earth in land area, not millions like the ringworld, though that's still a lot of living room. What is neat about these is that if you go for a thick ring rather than a big cylinder, you can set it in a normal orbit around a sun, but slightly cocked on its axis, so that it spins around once a day and gives you a normal day-night cycle. Indeed, if you give it a decent tilt like Earth has, it can even have seasons, though you will get a big eclipse every year, and the seasons won't change with how far north or south you are. For the ringworld, you need to instead use sun squares, another inner ring with dark and clear patches that spin relative to the ringworld, to move those patches overhead once a day to produce night, otherwise it's eternal noontime sun. Now in the book, this means simple dark, then light, very little transition time. But if I were building one, I would have a single solid ring where even the clear patches had material there to block more harmful frequencies of sunlight. And I'd not have just clear or opaque, but translucent areas to simulate the dimmer light of mornings and evenings. Indeed, there wouldn't be translucent or opaque either, but reflective, so I could bounce that light to some energy collector. Another aspect of Dyson shells or ringworlds is that while we always say 1 AU from the sun, and of course that distance would be different for other stars, we would actually want them further out. Earth's surface area is not twice our cross-section of light that we get from the sun, but 4 times as much, because we're a sphere, not a disk. If you don't need the energy coming off that star for other things, which you really do not since the ring is not a full shell, so there's plenty more sunlight to use, then you would actually want to go bigger yet. And instead of having that inner ring having opaque, translucent, or reflective segments, have it be made of a lot of lenses and prisms that concentrated light into bands or spots instead. It still lets you simulate day-night cycles, but lets you use all of that light, and also lets you vary the colors coming down on a spot. More red for mornings, less light at certain times of the year, more or less light at certain latitudes to simulate north and south polar regions versus tropics, rather than a monoclimate. So while in the book these are sunshade squares, I will simply call this inner ring the light ring, and it can have power collectors on it too, sticking up further north or south, along with radar and lasers to help blow up meteors. We'd want more on the outside edges too, but the actual shell has a few features of note also. First, a Ringworld takes an insane amount of mass to build. It has over 1 million times the land area of Earth, and matter isn't cheap, so you would want to have dips and rises in the outer shell to let you do deep oceans and tall mountains without using tons of mass and needing an even stronger shell. It's a good idea to keep your oceans fairly shallow and make your mountains hollow or full of something like aerogel too. Second, your typical Ringworld should have 2 huge mountain ranges that extend above the atmosphere at each rim, because you need to have walls there to keep the air from spilling out. Once it leaks over the side, it is gone, because even though these things are far more massive than a typical planet and have a decent gravity well, they are spinning far faster than their own escape velocity. This makes it quite handy to land or launch ships moving at fast interplanetary speeds from, or even slow interstellar speeds, but it means those air particles are going to zip away right out of the solar system and indeed the galaxy eventually. It's that fast. So you want walls to keep the air in, and you might as well stylize them as mountains a few hundred kilometers tall. You might even want to keep concealed vacuums in them to suck air back down and further minimize the leakage. Adding machinery to artificial planets always seems to bug some folks, but no megastructure lacks them. They are always there, automated or not. And Ringworlds are not actually in stable orbits, so they do need corrective thrusters on top of an impressive point defense system. You can probably use light rather than fusion or chemical rockets to provide the thrust to keep the ring stable. It is fairly stable over the short term, but you still need thrusters for corrections. I like to think that in the interest of robustness, the builders would use simple technologies like light to keep things going, and probably some other form of relatively simple system for corrections too. As we've discussed before, you can use light as a propellant. That is one thing I do get a kick out of though, this notion of some advanced species building something like this, then falling back to primitive technology so they can't maintain it. That's vaguely plausible on a regular old Earth-like artificial planet, but when you have got 1 million times the living area, even if you fell back to hunter-gatherer technology and population densities, you still have many trillions of people. And even primitive agriculture should get you close to 250 people total. Even following a collapse, you would think technology would be prone to catching on in a few places here and there, and then spreading. And if you have some collection of kingdoms somewhere just hitting the industrial era in a tiny corner of the ring, just a few hundred times the size of Earth, they ought to be fielding an awful lot of scientists and inventing technology again awful quickly. And once you have light-speed communications from phone and radio again, you could easily have a modern-era civilization with 1 trillion professional scientists working to reinvent technology that they have examples of all over the place. Dark Age megastructures are fun in fiction, but not terribly plausible. I do get asked a lot what the inside of rotating habitats look like, and the answer is that it varies a lot, depending on their size. In the smaller ones, the sky looks like your neighbor's backyard. The horizon curves up and wraps overhead and back down. That is one of the reasons I generally suggest lighting them from the inside and simulating a sky through brute force technology. In other words, stick another cylinder inside it and paint it blue, or go a bit more elaborate with holograms or TV screens simulating the right look and lighting. For one as big as a Ringworld though, you don't see the horizon rising up, and the other side of the ring will look like a blurry blue-green thing, since at those distances, continents are smaller than a dot in the highest resolution a human can see. With a simple telescope, you could see them though. Of course, the sun is rather in the way of a clear view. But as to the horizon, the curvature is so small that there just isn't one. It will eventually be broken up by the terrain or by the air itself. On the sea or a very flat area, or seen from a great height so land isn't in the way, it would seem like a hazy band where sky blends into earth or sea, probably with a red tint, like a perpetual sunset. I suspect you'd probably have a lot of smaller mountain ranges dividing areas up too. Lots of hills and valleys are a good way on any large rotating habitat to remove the appearance of a weird horizon. Now we are normally only looking straight up through about 10 kilometers of air. In the mornings and the evening, the light is coming in at an angle, so it passes through a lot more air, thus the reddish color near the sun rainbowing outward. Here, the reflected light of the rest of the ring has to pass through a lot of air to get to your eyes from the parts near you on the ring, so it will re-emerge like a giant rainbow arch across the sky from over the non-horizon once the amounts of air in between you and it, both by your and by its position, drops to enough to allow clear vision. So people on the ground will see this more like a giant glowing bridge across the heavens, though your inner light ring will interfere with that too, depending on how close to the ground it is. Get up on a tall enough mountain and you might be able to tell it's a ring, and if folks have telescopes and communicate with folks decently far away, their maps of that sky bridge are going to start making it very obvious they live on a big ring that bridge is part of, not a big flat earth with a bridge over it. Same as we realized we live on a big flat planet that just seems flat close to it, but is curved over very big distances. When it comes to weather, overall it's fairly similar. At this kind of scale, the issue of being on a ring that is spinning to make gravity versus a sphere that has gravity and spins to produce its weather is not too big of a difference. The important thing though is that you do want to have mountain ranges and go for relatively normal sized continents and seas, rather than trying to make continents 100 times bigger than Eurasia or oceans 1,000 times the size of the Pacific. This helps make sure storms can't build up over huge distances, and that water evaporating on an ocean can get deep into a continent. Indeed, when making your own land masses, by and large, big chains of big snaky islands and shallow seas is probably best. You might be able to make continents 100 times bigger than Eurasia, but you probably want to keep most of them the size of England or smaller, gives you a lot more coastal real estate. And while I'm sure you would want some deserts and tundras, I don't think you would want as much of them as we have on Earth, percentage-wise. These things have a ton of space, but there's no point being wasteful with it. Build mostly the land you like, and use smaller proportions of the kind you don't. If you are low on space, make the ring wider, or build another at a different angle. Multiple Ringworlds cocked at angles can form a Dyson Sphere. Again, these things also take a lot of mass to build, depending on how wide you want to build one, north to south, and how deep you want to make the land. You could disassemble all your own planets, and even mine out neighboring solar systems to build one, but as we discussed before, most of our solar system's heavy elements are in the sun, and there's more than enough there to build one if you can get star lifting working. Okay, so those are the basics of a Ringworld. And you might be asking why I even cover this in detail when I said earlier we had no material strong enough that we could ever make them from, and I did say we have a couple tricks for that. You don't necessarily need one though. There is a variation of this Niven explored in another novel called Smoke Ring that was a naturally occurring object, but the Megastructure version is just a giant glass donut around a star orbiting at normal speeds with an atmosphere inside. No gravity, but you could stick some smaller rotating habitats inside it, and if you like flying and don't care for gravity, it works without needing super materials. I think Peter Hamilton included one in his Commonwealth saga too, another good series. But if we want gravity, again we do have some tricks. The first one is that we might one day learn how to make such materials. We have a concept called magmatter, that is a hypothetical material you might be able to make if magnetic monopoles turn out to be possible. This could permit matter that is ridiculously stronger than even stuff like graphene. We also have to keep in mind that normal materials have their strength based on the strength of electromagnetic bonds between atoms. The force inside atomic nuclei are different and stronger, and for that matter, all the cool materials we make are based on protons and neutrons made out of up and down quarks. There are 4 other types of quarks, and someone might figure out how to mass manufacture them and make stable stuff out of them someday. For that matter, when we say normal matter, it's worth remembering that dark matter is actually normal matter since it makes up most of it. Not really fair to call it exotic when it's the majority, and we know next to nothing about its properties. Now, what we do know about it makes it very unlikely you could build anything out of it. Its incredibly weak interactions with everything else, including other dark matter, is about its only known characteristic. But it's worth remembering in the sense that we haven't finished exploring all the options yet, and even graphene and carbon nanotubes are only a generation old. However, we do have an option inside known physics and materials. We've talked a lot on the channel about active support structures, and how you can use them to make space elevators, for instance, if you can't find a material strong enough. Instead of a super strong material you hang down from orbit, able to hold its own weight, you use a stream of fast-moving matter to push and hold a structure up, like holding something aloft by hitting it with a stream of water from a hose below or a piece of paper floating over an air vent. You can't quite do that trick with rotating habitats. However, we can use a trick a lot more like an orbital ring, another megastructure and active support device we have looked at. There, we had a ring spinning around the Earth at greater than orbital speed, with magnets on it over or around which something stationary to Earth hovered. Their net momentum, spinning section and stationary section, was kept the same as if the entire thing uniformly moved at orbital velocity. You can do this same trick with a Ringworld by having a stationary ring just outside it, or even slowly counter-rotating. It does have to be way more massive though, but it could be mostly hollow and full of cheap hydrogen and helium. Makes a nice protective barrier too. The ring wants to rip apart from all the centrifugal force on it, same as a suspension bridge wants to rip apart from all the gravity on it. But if you stick pylons under the bridge, you can make it longer. That somewhat defeats the point of a suspension bridge, but that hardly matters for the Ringworld. We want all that speed for making spin gravity. So it can spin around terribly fast, trying to rip itself apart, while being magnetically shoved inward by the outer ring. Since the Ringworld is moving 1200 kms, 40 times faster than the Earth orbits the Sun, the outer ring needs to be much more massive to balance out the momentum, but hydrogen and helium are quite a lot more abundant than the heavier elements we want to build the ring from anyway. Besides being the only way to make one of these with known materials, an outer non-spinning ring provides a nice way to keep the structure from being punctured, which would drain all its air out eventually, or ripping itself apart if structurally compromised. Though in terms of features, you might use chains of mountain ranges to act as interior air walls, so only one area would drain of air if punctured, and have tunnels through those with airlocks, and tunnels to the outside from there too. For my part, I think the Ringworlds we looked at in the Dyson Sphere episode make a lot more sense to build than Ringworlds do, and they are of the same scope and can be made contiguous so you can walk, or at least float in some places, from one section to another. Still, there is something truly awesome about the concept of an enormous single planet you could walk or swim all the way around, 1,000,000 times larger than our own planet, which is hardly small. I think that's part of what makes the journey to and around the place in the book and its sequels so engaging. Niven never hesitates to make up advanced technology in his novels either, but where he does, he makes it clear that he is, and how it works and what its limitations are. Otherwise, he tends to keep his science very accurate, and where he misses the mark, it is almost always because the novels aren't too recent. Ringworld itself was published 47 years ago, and science has progressed since then, though Niven is still actively writing as he approaches 80, and has produced no shortage of excellent books. And while he is good about remembering the science part of science fiction, he does weave some fascinating characters and stories. Ringworld ties for my favorite by him, the other being A Mote in God's Eye, which I consider one of the best handled examples of forced contact with aliens in fiction. Niven writes fascinating aliens who are actually alien in appearance and manner, and we get to meet a few of them in Ringworld too. Again, it is our SFIA Book of the Month, and is available on Audible, and you can pick up a free copy today. Just use my link, audible.com/Isaac, or click on the link in the description below to get a free audiobook and a 30-day trial. That's audible.com/ISAAC. I'm certain you will enjoy that story, but if not, you can swap it out for free for any other book at any time, and it is yours to keep whether you stay subscribed to Audible or not. Ringworld is a great way to immerse yourself into one of the most thought-provoking sci-fi settings, with dozens of novels and short stories. Let me know what you think of it in the comments below, and let me know what book we should listen to next. Next week, we will be celebrating the 100th episode for the channel, which coincidentally is also the 3rd anniversary of the first episode, by returning to the Alien Civilization series for a look at the Zoo Hypothesis, the Fermi Paradox solution that argues that aliens avoid contact with primitive civilizations, and some examples of it like the Star Trek Prime Directive in Smug Aliens. The week after that, I'll be teaming up with Jean-Michel Gaultier to look at the opposite case, where you intentionally contact and even alter technologically primitive species, like making smarter dolphins with hands, in Uplifting. For alerts when those and other episodes come out, make sure to subscribe to the channel, and if you enjoyed this episode, hit the like button and share it with others. Until next time, thanks for watching, and have a great week.